Hello everyone, welcome to today's class. In this lecture we are going to discuss about binary operations. So we have to think for some operations, and based on certain criteria we can call them as binary or not. Okay. In order to understand, let's take one illustration. First of all, let's understand like addition. So let's say a plus b is there, so we can kind of think this generates a new function effectively. Okay. Addition itself is a function in which we are taking two elements and we are adding them. Okay, it's a function, and this function generates, what does it generate? It generates a unique number or unique value. Okay, so suppose we are performing this on addition. We are performing this on set n. A is belonging to set n. Okay, A and B both belongs to, let's say, natural number, some set natural number. So this unique value should also belongs to the natural number. Okay, so since we are doing an we are generating a function which is adding the two numbers, basically we are writing unordered paired. Okay, so that ordered pair a comma b is resulting in some value, and that should also belongs to this set of natural number. First thing. Second thing, it should be a unique value. So there are two conditions, I'll say. First, it has to be a unique value. Second, it has to belong to the same set of this. So basically, if I denote this notation wise, so addition is happening on two sets such that it is from n cross n from two natural numbers, and result is also n. Result is also from the natural number sets. Okay, so we can call this addition as a binary operation. Okay, this n cross n is like a comma b, na? We write ordered pair. So ordered pair are represented by the Cartesian product. Na? This is a representation of Cartesian product. Okay, now let's write. Now that we have understood, there are two parameters. First is it should generate a unique value. Second thing, it should belong to the same set from which a and b comes up. Okay, so now let's write the final definition. So a binary operation on set S associates each ordered pair a comma b from S cross S to a unique element. So we'll call that unique element as f of a comma b. Okay, f of a comma b, some function is used between a and b, and we got a unique value, and it should also be in S. Okay, in S means it should belongs to S. Okay, if you are unable to understand this, consider this as belonging to S. So the elements will choose from the same set, and the result should be also from the same set, and they should result in same value. Okay. That's the definition. Okay, I know, kind of weird, but try to understand like from these two ideas. Unique value should belong to the same set. So mathematically it is written like that. Binary operations definition is f is such that S cross S, the ordered pair results in also S. Okay, now how do we represent? So every time I don't want to write the element as f of a comma b, a comma b. So what it is written as, this gets modified to a function of b, and then instead of writing f, we write this as a star b. Okay, where star is the binary operation. Okay, so this is the effective symbol for binary. Now let's check whether addition, subtraction, they are binary operations or not. Also we have to define on which set. Okay, so let's take few illustrations. Okay, example. Let's check addition, although we have already checked, but see addition and on set of natural numbers. Okay, so a plus b. Okay, if we add a natural number to natural number, the result is also a natural number. Definitely, you try to think yourself. If you add any two natural number, the result is also a natural number, and of course it will be unique, like 2 plus 1 will be 3. Okay, it will not be different, like 2 plus 1 is 3, that's fixed. So it has a unique value as such. Okay, a comma b should have a unique value. 2 plus 1 can be 3 or 2 plus 2 can be 4. You cannot have 2 plus 2 comma 2 as 3. Okay, so unique value and also belonging to set. So yes, addition is binary. Okay, we know it's a unique value. Okay, let's check it like this. A plus b, of course it is going to be a unique value, and this is the first point checked. Second point, you have to check that natural number adds to natural number should result also in natural number. So yes, also belonging to n. So both the conditions are being satisfied. So definitely, therefore both the conditions are satisfied. So we can say that addition is binary operation. Okay. It's a basic definition that you have to understand. Subtraction, let's check whether it is a binary or not. Again, we have to define on which set. Subtraction on set of natural number. So I'm on set of n, I'll write. Okay, n is for natural number, na? So a minus b, of course we know it's a unique value. Subtraction, there is no problem with that. But is it true n minus n is also n? Means if you subtract two natural number, will you get always a natural number? No, because if you take like 5 minus 7, it's minus 2, definitely doesn't belongs to n. So we can say, since this condition is not followed, we can say subtraction is not binary, but on natural number set. Okay, it can be binary if it was integers. If the same question is in integers, na, subtraction on set of z. Okay, so integer minus integer is always integer, of course, and it will be on unique also. So then it will be a binary. So again, it is dependent whether it is asked on set of natural number or set of real numbers, set of natural numbers. Okay, positive rational numbers, negative rational numbers, something like that. So it depends on that. Subtraction we have checked. Let's check multiplication also now. Let's do it now quickly, now that you have understood two basics. Multiplication, on set of natural numbers. Again, a multiplied by b, unique value, that's not a problem. Of course, 12, 2 into 3 will be always 6. It cannot be anything else. So we get a unique value. Now, is natural number multiplied by natural number is always a natural number? Yes. So both the conditions satisfied? Yes, it's binary. Division. Now I'm doing this on set of only natural number. You can take this as a practice check for set of z, for set of rational numbers. You can verify set of real numbers also, you can check. Okay, so division, again a by b, of course the value will be unique, but the point is n divided by n or n slash n. By doing division, n upon n, will it result also in n, a natural number? Not necessarily. Again, you can take an example of like 3 upon 5, it's 0.6, definitely not natural number. So this condition is satisfied, this is not. Both the conditions should be correct. So no, it's not binary. So binary operation. Okay, I hope you get some idea. Now we have done this for only basic operations that you already been seeing. Now let's take a look at some new operations. Okay, any operations can be generated according to this. The question will give you what kind of operation is performed. So let me take another example. So let S is 1, 2, 3, 4. Okay, 4 elements, and we have defined A star B is R, where R is least non-negative remainder when product is divided by 5. Now if we take any two numbers and multiply them, it will result in anything. I'm not worried about that. The point is, if you divide anything by 5, of course the remainder will be less than 5. You cannot have remainder as even 5. So I'm pretty sure that whatever operation I perform, okay, so let me show you a few examples first. Let's take 1 star B. So what I have to do, I have to write down the result is the remainder, non-negative remainder, because there is a concept of negative remainder also, but don't focus. If you have done aptitude, you might have some idea about that, otherwise forget about that. Right now you focus on your basic remainder that you study in schools. Okay, that's the positive remainder. Okay, and so you have to multiply them. So multiplication is 2. When 2 is divided by 5, what's your remainder? 2. Okay, similarly let's take some big numbers. Let's take 4 star 3. The result is 4 into 3, and then you have to divide by 5, and you have to write the remainder only. 4 3s are 12. 12 divided by 5, what do you get a remainder as? 2. Okay, you can take any other combination. 2 star 3, that's 6. 6 divided by 5, remainder will be 1. So you're seeing that every time we are multiplying that, we are getting definitely the values, whichever values we'll get, of course they will belong to this set S. Of course we are getting unique values, like 1 star 2 is one unique value. One unique value means we will not have 1 star 2 as 2 and 1 star 2 as 3 also. So by putting the value of A and B as 1 and 2, we are getting one single value. Okay, so of course we are getting a unique value, and they are belonging to the same set. This is like 1 2 I have taken from set S, and the result is also from the same set. Both the conditions satisfied, so definitely binary operation. Okay, so we had to check whether this operation was binary. So yes, it's binary. Okay, all right, no need for this. Let's take another one. There are certain two functions. Okay, one is A like this, B. Okay, the symbol can be in any form. Okay, and then there is A like this, upward arrows. It's called this is called maximum of A and B. Okay, this is called minimum of A and B. Okay, so you have to check whether A maximum of A and B and minimum of A and B are binary operation binary operation of R, means on the set of real numbers. So I think that will be very easy, even if they would give it to you in terms of natural numbers and on the natural numbers, still you can check. So let's take few examples to understand again. Let's take 5.3 and 3.7. Okay, and we are doing maximum one. Let's check for this. Maximum is written by 2.7. So of course the maximum function will select the maximum out of these two functions. Clearly the answer will be 5.3. Let's take something like root 2 and root 3. Okay, which one is maximum? Root 3 is maximum, we know that. Okay, so anyhow, both, if we take, of course we are getting a unique value again. Like for these two values we will always get 5.3, we will not get anything else ever. So of course we are getting a unique value, and the values that we are getting of course are from A and B. Either we'll get A as the answer or B as the answer. A and B itself belong to R, so the answer will also belongs to R. So both the conditions are satisfied. It is a unique value, it has a same set of R. So yes, A maximum of B, sorry, maximum of A and B is binary. Okay, and similarly you can suggest the minimum function. Okay, so I'm not solving that now, pretty much you can understand after this. Similarly, A minimum of B, minimum of A and B is also binary. Okay, operation. Okay, the other names of this you should know. This is called supermum. Okay, and this one is called infimum. Okay, sorry, infimum. Supermum. This is, let me write it properly. SUPERMUM, supermum. This is called infimum. Infinum, I mean. Okay, these are the other names of this. Although don't worry, they will give you that this is the definition of this. You don't have to learn it, but is the notation basically followed? Okay, like greatest integer function. Whenever the question will give you any function as greatest integer function, because it's just a bracket. So they will justify it that yes, this bracket represents greatest integer function. Okay, so no need to learn it, just extra information here. Okay, all right. Let's see another example. A star B. Okay, the operation is defined by A raised to power B. Check whether it's binary on W. W is our whole number. Okay, so let's check it. 1 raised to power 2, it will be 1. Okay, sorry, 1 star 2 means 1 raised to power 2, so 1. Okay, so it has a unique value. 1 2 will always be 1, it will not change. Okay, and 2 star 1 will be, let's say 2 raised to power 1, that's 2. Okay, 3 star 4 will be 3 raised to power 4. Okay, so something 3 raised to power 4 over 81. Okay, so as such we are getting unique values. Okay, the point of unique value is that the result should remain same as long as you have the value same. You cannot have two results like plus minus 1 plus minus 2 or 1 2 3 4, like that. Don't like that. Okay, and they all are whole numbers also. Okay, so both the conditions satisfied or not? Yes. Yeah, so as per that it's binary. Okay, but you have to consider all the possibility. What is the one possibility that could ruin this is 0. Okay, when see whole number, what is the difference between whole number and natural number? 0. So that 0 can create a problem. So let's check for that. Okay, before moving it to for any other value. So 1 star 0 is 1 raised to power 0, that's 1. Okay, no problem. Then 0 star 0, sorry, 0 star 1, that is 0 raised to power 1 is also 0. So no problem with this. What about 0 star 0? I mean, it's not necessarily every time you have to take two different values. Okay, you can take same values also, like 2 stars 2, that's 2 raised to power 2, that's 4. So 0 star 0 is 0 raised to power 0. Now what is 0 raised to power 0? And don't say 0, of course. 0 raised to power any number, any natural number or real number, we can say it's 0, but as long as it has a value. As such, you should know from limits, this 0 raised to power 0 is the case of limits, so it is not defined. And if it is not defined, we can say this doesn't belongs to whole number. And this is the only condition which is making this not binary. Okay, so this is incorrect. We are getting whole numbers for all the values, no problem. It's just that 0 star 0 is not defined. It's a case of limit, so we cannot solve this. Okay. It's a meaningless thing as such. All right. Next, let's talk about types of binary operation. Types of binary operation. First is commutative. Sorry. Commutative has same definition, pretty much you can guess. It's A star B should be B star A. Okay, means if you change the order, the result should be same. That's commutative. Okay, but it's just that now we are doing it for binary operations, so I put star, so that operation can be anything. Associative suggests that A star B star C, you do it in any order. Suppose you do this, or A star B star C, they should result the same. That's associative. Okay. And then you have the distributive. Okay, for distribution there are two operations involved. Okay, because we have to distribute the operation, so we'll involve two operations. One is, let's say, star. Okay, and one is like this. Okay, I'm just using random symbols. Okay, so don't get worried like what is the meaning of this symbol, what is it? Both are binary operations. It's just that I cannot put star because star will imply that it is the same operation. No, these two operations are different. It's like if you want to understand, it's like A into B plus C na. So you, in order to check distributive property, you use two different kind of functions. Okay, all right. Yes, so we are using two different kind of binary operations on this, and the distribution should go like this, that A star B then dot A star C. If you want to again relate it, better relate it with this, like A multiply by B plus C, it's A into B plus A into C na. This is the distributive property that we actually study. So just trying to relate it with a binary operation like this. Okay, all right. Okay, next is binary operation. Now we have to check whether certain operations are associative or not, commutative or not. You have to know how to check them. Okay, so basically we have to check these operations are being valid or not. Okay, let's see an example. Okay, So A star B is defined as A plus B plus AB by plus AB only, okay, not AB, okay, and for A comma B belongs to all real number, okay. So this is defined for some real number, and you have to check commutative and associativity. Okay. Now for associativity we have to first of all get A star B, which is already given, A plus B plus AB, okay. Now if we are doing B star A, all we have to do is replace A and B, so B plus A plus BA, okay. BA is multiplication, so we can again rewrite this as A plus B plus AB, which is same as A star B, so clearly it is commutative, both are same, so commutative. Next we have to check for A star B star C. Let's do this first. So A star B is A plus B plus AB, and then we have to put binary operation on with C also. So what is happening is you add them first of all, so I have to add both of them, both the elements need to be added, so A plus B plus AB plus C, and then add their product also, so A plus B plus AB into C, okay. So A plus B plus AB plus C plus AC plus BC plus ABC. Okay. Now we have to check for A star B star C. Now we'll do for B and C first, okay. So A star B star C will be add them B plus C, and then what, add the product BC, and again same thing, add the elements, so A plus B plus C plus BC and their product, so A multiplied by B plus C plus BC, so A plus B plus C plus BC plus AB plus AC plus ABC. So these three, this one, they are all same, AB plus BC, A plus B plus C is also there, ABC is also there, ABC also there. So yes, they are equal, both the results are equal, so we can yes say it's associative also, okay. So this is the way you can check if something is a commutative, associative or not, okay. Let's pretty much take the same function. One more example, A star B this time is A minus B plus AB, okay, and for all A comma B belongs to Q. Q is set of rational numbers, okay, set of all rational numbers. So again discuss their check commutativity and associativity. So A star B is A minus B plus AB, whereas B star A, now change the order, replace A and B, so B minus A plus BA. So you can see they are not equal, which implies not commutative. Okay. Same way, now check A star B star C. First of all, for this, so this becomes A minus B plus AB star C. Now what does that do? Operations, first subtract them and then add their product. Subtract these two, A minus B plus AB minus C, plus their product, A minus B plus AB, and their product is with C. So this is A minus B minus C plus AB plus AC minus BC plus ABC. I'm getting a feeling it will not be associative also. Okay, A star B star C. So that is, first of all, we have to do B star C. So A star B star C will be B minus C plus BC. Okay, subtract and add their product. Now for these two, subtract, so A minus B minus C plus BC, and add their product, so A into B minus C plus BC. So that's A minus B plus C minus BC plus AB plus, not plus, minus AC plus ABC. Okay, so A matches, B matches, C doesn't match, it's minus C here, it's plus C. The moment one element doesn't match, that means they are not equal. So not equal again, these two not equal, so not associative. Okay. All right. Okay. Another question, one more on the same thing, associative. This time A star B is HCF of A and B for A comma B belongs to natural number. We're talking about that. So we have to check again the associativity. First of all is find, check commutativity and associativity. So A star B is equal to HCF of AB. B star A means HCF of BA. So whether you take HCF of, for example, whether you take HCF of 4 and 12, or you take HCF of 12 and 4, the result is always the same, na? HCF is 4, 4. So they are equal. Okay, you have to think. You don't have to actually solve anything. It's all about thinking. Whether you take in the numbers in any order, the HCF is the same, so they are equal. Okay, this is the proof of it. You can see, and yes, they are. HCF is commutative. Then A star B star C. Okay, I think it will be better if I illustrate this with the example. So let's take 4, 8, 12. No. Let's take 4. Let's take 10. Then let's take 15. Okay, I can take 30 also. Let's take 30. Otherwise you'll think that I've taken the set of all co-prime numbers which are resulting in final HCF as 1. Okay, so these are the numbers we are going to take, A, B, C. Okay, let's do A star B star C in this order. So first of all, HCF of 4 and 10, that's 2 star. Okay, so I'm done. 4 star, 10 star, 30 with this first. So HCF of 4 and 10 is 2 star 30. HCF of 2 and 30 is 2 itself. And let's do A star B star C with this first. So 4 star 10 star 30. Okay, so HCF of 10 and 30 is 10 itself. So 4 star 10, and HCF of 4 and 10 is 2. So both are again equal. Also, if you can recall, suppose you have to take HCF of like 4 numbers. How you used to do is take HCF of 2 numbers, then take HCF of other 2, and whatever result you got, you take HCF of that also. Although you don't do it like this now, you can take HCF of 4 numbers together. But the idea is like A, B, C, D. Suppose 4 numbers are there, na? So you take HCF of these two, HCF of these two, then combinedly you take the HCF to get the final one, if it is complicated. Okay. So there are, so we can see HCF is a binary operation which is commutative as well as associative. Okay. All right. I think that's enough idea regarding associative, commutative. Okay. All right. Now let's talk about identity function and inverse function, because this is the last thing that you need to understand. Identity and inverse. Okay. Most of the questions are either about commutative, associative, or this identity and inverse. So let's understand first of all identity function, because without that you cannot understand inverse. Okay. So identity function goes like this. It should follow this definition: A star E should be A, and it should be same as E star A. So first of all, the function, you can see A star E and E star A equal. So basically he's saying that the function should be commutative and both results should give you A as the value. Means the element on which you perform binary operation with some element E, it should result in same element. If this happens, okay, E is called identity element. Okay, now I'm going to give you some illustrations, basic ones, very simple ones. Like for addition, try to think for addition. Okay, what should be E? Okay, so 1 second, I'll create sort of a table so it will be better. Let's create a basic table. Okay, so on this side we'll write operation. Okay, and on this side we'll write the identity element E, or identity element. No? Sorry, I have written identity function, it's identity element. All right, let's talk about addition. So A plus, so I'm replacing star with plus now. Addition is there. E should be E plus, should be A plus E, sorry, should be A is equal to E plus A. Of course, so we know it is addition is commutative. What should I add to A so that I get A? What should be here? 0. So 0 is called the identity element of addition. This is something that you may find it in grade 6th 7th NCERT note book also, but there you just learn it, you don't understand how that identity function is written, although this is written a plus 0 is equal to 0 plus a is equal to a, that's why it is called identity, but effectively there is no basic definition of identity function. Now you are getting that basics. Okay, the first of all you are understanding binary operation and then finding this E element. Okay, for subtraction, of course subtraction is not commutative, we have already seen that, so we are not talking about identity element of a subtraction. So remember that it is defined only if it is commutative. Now for multiplication, okay, so for multiplication, it's like a multiplied by e should be a and it should be e multiplied by, of course 2 multiplied by 3, 3 multiplied by 2, same, so commutative is there. Now what should be this e? Try to think. 1, a into 1 is 1 into a is equal to a, so for multiplication 1 is the identity element. Okay. Now it's not necessarily it's always for operations, we can consider it for like addition of matrices. Addition of matrix. So in matrix addition, it should be like a plus some E matrix, of course it will be matrix, should also be a, should be e plus a. Of course we know in addition also matrix addition is also commutative. Okay, a plus b is same as b plus a matrix wise also, but what should be this? E matrix should be a null matrix. So I am writing this, but remember this is alphabet O, it's null matrix or zero matrix. Okay, null matrix or zero matrix. Okay, so for addition of matrix, null matrix is the identity. If you are talking about addition, we should talk about multiplication also, multiplication of matrix. So for multiplication of matrix, try to think. Multiplication is like a into some E matrix should be a and it should be E into a matrix. What is that? Identity matrix, because identity matrix into anything, a into identity matrix is identity matrix into a is equal to a. So your identity matrix, this is, and now you can understand why the name identity matrix is there. Okay, where we got that name, it's an identity E. Okay, we can get this in terms of vectors also, like for a addition of vectors, what should be identity of that identity element? So for vector, pretty much it is same, a vector plus some e vector should be same a vector and should be e plus a vector. Addition again in vector is also commutative, but what should be this e? This should be a zero vector. Okay, zero vector. All right, this was the basic for identity element. Now let's find it for some different operations also, like let's say a star b is 3ab by 7. Find e. E is identity element. Okay, the question will say identity element, so you just follow the definition. A star e should be a. Okay, so a star e is, use this definition now. A star b means 3ab upon 7, so a star e means 3ae upon 7 should be a. Okay, and you can write this also, e star a, so still same thing, 3aa upon 7. So same thing, basically we solve these two only, cancel a and a. What is the e element? 7 by 3, that's your answer. So you can find any identity element as per the operation. Also one more thing, I forgot to define on which element it is are defined. Okay, so A comma B belongs to real numbers. R0 means real number without 0. No 0 is allowed. Okay, real number minus 0. Okay, whatever the element comes, this should belong to this set also. Remember that. Suppose you are getting 0. I'm just saying, suppose you got 0 as this, E as 0. So if that is defined in this domain, if it is valid in this set, then only you can take this as identity element. 7 by 3 is a real number which is not 0. So yes, we can take this. Otherwise you cannot. Okay. Suppose it was coming negative number and here it was given natural number. So I cannot take E as a negative number because it doesn't belong to the set R. Okay. All right. Let's see another one. A star B is AB by 2 for A comma B belonging to Q plus. Q plus is set of all positive rational numbers. Okay, this you should know from sets, but still, set of all positive rational number. Okay, so A star B is AB by 2 na? So the definition goes like this. So in order to solve, again you need the basic definition of identity element, that is A star E is equal to A is equal to E star A. So star is multiply by them, operation is multiply them and divide by 2. So AE divided by 2 is equal to A is equal to EA divided by 2. So clearly first and last are same, so solve these two only. A cancel, E is 2. Now check whether this belongs to Q plus or not. Yes. So it's belonging to this set. So yes, it's an identity element. If suppose, if hypothetically, if E came minus 2, now clearly this doesn't belongs to Q plus. So in that scenario, no identity element is there. So it's not necessary every operation should have an identity element. It depends whether the element that is coming will belong to this set or not. Okay. All right. Now another question, last. A star B is equal to square root of A square plus B square. For this you have to find the identity element. A comma B belongs to R, so very safe. Real numbers are very safe because everything is included na? So A star E is equal to E, A is equal to E star A. So square root of A square plus B, E square is equal to E, A is equal to E square plus A square. Okay, so we have to solve these two only because these are same. So A square plus E square is equal to A square. So A square cancel, E is equal to 0. So of course, but before writing that as a final answer, this is belonging to R, therefore 0 is identity element. All they have to do is write here R0. R0 means all real numbers but not 0. In that scenario, this will not be the answer then. Okay. All right. Last inverse of a binary function. Now in order to find inverse, you need identity element. That's why we discussed that. Inverse of binary operation. Sorry, inverse of element as such. All right. inverse is something like, the definition goes like this again for this, like A star B, okay, is equal to E is equal to B star A. Kind of like you can relate it with matrix na? AB is equal to BA is equal to identity matrix, so B is called inverse of A. Same here, okay. If this condition happens, okay, this is the condition for inverse of an element, then B is inverse element of A. Of course you need E for that, and E you know how to calculate now, okay. So let's do one question to understand this better. A star B is equal to AB by 5. A comma B belongs to Q0. So Q0 means all rational numbers except 0. Okay. So first of all, let's find E. Step 1, find E. So A star E should be A. You know, but it's going to be E star A also. So that is AE by 5 is equal to A cancel, E is 5. Step 2, now use the find B. Okay, now find B. So A star B should be E. Of course it is going to be B star A also. So A star means AB by 5 is equal to E is also 5. Okay, so what is B? 25 by A. That's the inverse element. Again, don't try to judge this based on your simple understanding of additive inverse or multiplicative inverse, although that inverse also interestingly comes from this. Okay, we completed one table for identity. You can calculate your generate one more table for your inverse. Okay, but it will be the inverse element of A. So for identity it is, you know, additive inverse is minus A, multiplicative inverse is 1 by A. You can actually generate from this same definition, and actually they come from this. It's just that earlier we were not having that much understanding. All you get to understand from teacher is that if the additive inverse of 3 is asked, put minus. If multiplicative of 3 is asked, put 1 by 3. Just reciprocate it, and we never question it. Of course, the ability to comprehend at that level, of course, is not that much, but still, this is the true reality of inverse, additive inverse, multiplicative inverse. Okay, let's put another operation into work. A star B is A plus B minus AB on set of A comma B belongs to set of rational numbers except 1. 1 is not allowed. Okay, so find inverse element. So again, for that use step 1, find E first of all. So A star E should be A. So A plus E minus AE is equal to A cancels. I can take E common. 1 minus A is equal to 0. So E is 0. 0 upon anything is 0, na? Alright. Step 2, find B. From where? A star B should be E. We have a E. So A star B is A plus B minus AB is equal to E is 0. We have to find B, so take A on the other side. So B bracket 1 minus A is equal to A, and B is A upon 1 minus A. You can see why they were saying Q should not be why a and b belongs to q but not -1, because then inverse element will not be defined. Okay, if they don't write this, inverse element will not be defined. Of course, from there we can see a should not be 1, so therefore a is all set of now this q is for rational number but 1. This should be actually plus a, na? So minus a, so put minus here, minus a upon 1 minus a, that's the inverse element. Okay. All right, let's take a look at this question now. A star b is equal to AB by 5. This is what we have done, na? AB by 5. So AB by 4, I think you can solve this for on your own, because we have done already AB by 5, so I'm not doing this. You can solve this on your own. So find inverse element. Okay. Practice. I'm not solving this. Next, associative. Let's take this. This is interesting. A star b is LCM of a comma b, and a comma b belongs to natural number. Find find e, and which elements of n are invertible. If it is saying which elements of n are invertible, that means the whole set of value of a is not invertible. There are certain values for which it will be non-invertible. Invertible means again inverse, so don't get confused with this word. Okay, let's find e first. So a star e is equal to a, so LCM of a and e should be a. Now try to think of a number. For this you can take an example. Let's assume, okay, if you are getting it, let's assume a as say 5 or 4 if you want. Okay, let's take 4, otherwise you'll say I'm taking prime number. It's a composite number. What is the LCM of 4 and something that is 4 itself? What should be this something? It should be, it can be 1 also, it can be 2 also. Okay, but this should be always applicable. So here I can say e can be 1 or 2. Okay, so there are 2 possible values. E should be a unique element, na? It's an identity element, so this is not clarifying us. So let's assume another value, a as, let's take 5 now. So 5 and e, now we are getting LCM. We are supposed to get the LCM as 5 only, so what should be this now? 1. Now this one suggests it can be 1 or 2 or something. This can be suggesting only 1, so definitely I can say e is 1, because if e is 1, always the LCM of a and e will be 1, will be a. Now a can be anything, 4, 5, 11, 12, anything. As long as e is 1, the LCM of them should be the number itself. Okay. All right. Now for this is part 1, second. Now for second part, now we have to find a star b is equal to e. So LCM of something, LCM of 2 numbers a and b should be 1. LCM is 1. As if I take a, see, we have to find b now out of this in terms of a. So let's assume a is something again. Assume a to be, let's say take same value 4 na. So LCM of 4 and something should be 1. Now when they will be 1, B has to be what? Is it possible? Point is that LCM of 4 and B is 1. Is it even possible? Of course the LCM is at least the minimum value or the product of that. Okay, if they are co-prime numbers, they will be product of that. Even if some factor is there, of course the answer will be, let's say B was 2, so LCM of 4 and 2 will be at least 4 here. Okay, if it is even 1, LCM will be still 4. So never you can have this LCM. Okay, that means as long as A belongs to some number, let's say 2, 3, 4, 5, you will never have the LCM as 1, because the B second number has to be anything, but your LCM will be either this value or more than this value. LCM is lowest common multiple, but point is the word is multiple. It will be more, or at least this value. It cannot go beyond this. It cannot be less than this. It can be more than this, but it cannot be less than 2, 3. So it cannot be 1. So as long as A belongs to this, no element, no inverse element. Now why I am not taking 1? Because now I can say if A is 1, if A is 1, now I can say 1 comma B, LCM of them can be 1 if B is 1. Okay, so this is possible if B is 1. Okay, so so this inverse element exists only if A is 1 and the inverse element itself, then B is also 1. Okay, so if A equal to B equal to 1, then only we have invertible matrix, and the value of the invertible of A is also 1. Okay, theoretical understandings. All right, I think that's pretty much all about binary operation you should know. Okay, so that pretty much summarizes this topic. I hope it is clear. Go through all the illustrations that I have done, and remember, this is not solving maths. It's kind of thinking more about maths. Okay, so binary operation, they are not difficult to solve as long as you have the definitions clarified, how things are working. Identity inverse, usually the question will be about that, find E, find A, and easy questions, not these kinds of confusing questions for this. Okay, but I'm not saying that they cannot be generated, but usually you'll get a straightforward questions, because the definition itself you might not be able to recall in the exam. Okay, so practice this. All right, that's it for this lecture. See you in the next class. Good day, everyone.